Okay, well, thank you again for tuning into This Automation Live, brought to you by Brenner-Fiedler. I'm your co-host today, Paul Oppenheim, and each week we discuss technologies used in automation. And this week, Jeremy Schubert, our automation specialist with Brenner-Fiedler, is here to discuss bearings. So thank you, Jeremy, for joining us today.
No problem, Paul. It's nice. I'm on the other side of the table. Which
Yes.
is actually a metaphor because we're on the same side of a table.
That's right, but they probably can't see
But
that.
nobody can see that.
So let's just kind of segue into our topic today, which are bearings, of course.
You want to know about bearings?
I would love to know about bearings, and I understand there are, I guess the two main categories are roller versus plane.
Well, there's a lot of categories.
Oh, okay.
But
so, take
I
it away.
think there's a good place. We'll start there.
Okay.
We could probably talk for days about them, though I wouldn't want to. Not that I don't love them so much. But no, roller bearings versus plane bearings. So you got two different technologies here, same goal out of each of them, and that's to be your surface that's moving. So let me use an example because I think that's easier than explaining.
Okay.
If you've got to move, let's a drawer in and out of something.
Sure.
You could use a plane bearing, you could use a roller bearing. So what's the difference? A plane bearing basically means that you've got two surfaces touching with no moving parts. So typically you're going to have two low friction surfaces, something like a Teflon plastic or something based in that, writing on maybe another plastic, maybe on aluminum, maybe on steel. It depends.
Okay. Is there something, let's say, for those of us who are not terribly familiar with bearings, where one might see a plane bearing, let's say in common everyday?
If you look at your desk and you've got a drawer that rolls out, like a keyboard tray or a drawer, that has some kind of bearing in it.
Oh, okay.
It could be a plane bearing. It could be, a lot of times, there's a rolling wheel in the back. So realistically, that's a roller bearing.
Gotcha.
So from what you got from there, everything else is all about size. How much weight, how fast are you going, etc.
Okay, gotcha. So I guess let's kind of get into that. Or is there some advantages to using the roller versus the plane based on weight, size?
Yeah, definitely.
Oh, okay, great.
So with a roller bearing, you've got this rolling element, and a lot of times that rolling element has built-in ball bearings, and it's sealed. So because of that, we'll use that as an example. You've got a steel wheel, just like a train, and inside you've got little balls that are going to rotate around another circle, if that picture makes sense.
Okay.
So because of that, you've got all steel contacting steel, which the harder the material and the smaller the point, the less friction there is.
Okay.
So if you imagine like a train wheel hitting steel,
Sure.
that's a very low friction point.
Okay.
So that's the idea, is you're basically recreating a train wheel to roll on some kind of rail.
Okay.
So low friction, so that's great. The plane bearing, you've got a surface contacting a surface.
Right.
So because of that, there's more surface area making contact, and there's more friction. So that's where everything works off of. If you have a really high load and you've got a really high friction bearing, then it's going to take more force to push that. So in terms of like backing that all the way out to an actuator, you have a really big motor trying to drive your actuator.
Gosh, well then it kind of seems just perhaps the untrained ear that the roller bearing seems to be the way to go every time. Why would I want to use a plane bearing, I guess?
Cost is a good one.
Ah, okay.
So a roller bearing, I mentioned all the parts that go into one little bearing.
Right.
So that, of course, is more expensive to manufacture than two surfaces that are just going to glide on top of each other.
Okay.
The other issue could be noise. Because you have little balls that are going around inside, you've got steel hitting steel all the time. They do make some noise. This isn't going to be like a diesel engine, but if you're trying to have a very quiet product slide in and out, you're going to have some noise there. Plane bearing is silent.
Gotcha. Would that also cause possibly vibration as well? If you're going with the roller bearing versus the plane, along with the noise, is there?
You can sometimes feel the actual balls as they kind of click and roll through.
Okay.
Part of that comes from the number of balls and the size, the quality of the manufacturing, how similar in size are the balls. So that can all kind of play into it.
Okay.
Sometimes I don't think I can feel it, and other people think they can, which is either a mental thing or an art. I don't know.
Gotcha.
So basically the difference you're going to say, like I have plain bearing, I've got cost, I've got, I want quiet. The other thing could be size and shape.
Mm-hmm.
It's pretty easy to make plain bearings kind of fit into the size and shape you need.
Okay.
You're kind of limited on the size for a rolling element of how small of one can you make.
Okay, that's true. Okay.
And then also you've got a specific kind of shape to a rolling element that's got to attach to things. So then it really becomes a fit type of function.
Gotcha. So if I understand this correctly, it sounds like if you're using a fairly small object, where therefore probably the weight would be fairly small as well,
Yeah.
it sounds like the plain bearing would probably be the kind of the way to go, regardless of cost, simply because just there's no ball bearings to work with or anything like that, where which would probably have to be fairly a little bit more larger in size just to actually make it, whereas the plain bearing is one piece on another piece. And so,
I think that's kind of some fair assumptions to make.
Okay,
The devil's always in the details, but
Right.
if you're going to kind of rule of thumb that, then that's where I would start.
Mm-hmm.
Armrests are a good place for a plain bearing because they can just slide in and out. There's not going to be a whole lot of weight.
Right.
One thing to watch out for with a plain bearing is a cantilevered load or a moment arm. So the rule is a 2-to-1 ratio. So what that means is if your force is being applied 2 times from a distance that's 2 times the length of the bearing, then it's actually going to act as a brake. So if you kind of picture your bearing and say it's 3 inches long, if you have something 7 inches away and that's like your handle that you're trying to push it on, it kind of makes sense that it's going to just increase your friction until it stops.
Right.
And part of that comes from, to make a plain bearing, you've got to have 2 objects that are close in size, but one slightly larger than the other, and so you have a little bit of play.
Right, sure. A little bit of wobble there, huh?
Yeah,
Okay.
wobble.
Yep.
And so when that wobble, you press on that wobble from far away,
Right.
you're basically making a lever that will stop everything.
Be working against you.
Yeah.
Gotcha. Right. Hence why you're talking about why you need a bigger motor to now you have to compensate for that.
You got to push through that.
That's right.
And if you can push through that and kind of break it free, what happens is it'll catch again. So when you're kind of on the gray area of that of the friction and the 2-to-1 ratio, you'll see it's called stick slip. So it looks kind of like a stuttering movement as it goes through, which people don't usually like that.
Right.
So.
Okay. Well, excellent. I think that's all the time we have for now. So thank you again for joining us this week. Again, my name is Paul Oppenheim, and thanks again for listening to Brenner-Fiedler's This Automation Life. And be sure to continue tuning in each week. In upcoming episodes, we will discuss additional automation.
I think we've got more like motor starters coming up.
Excellent.
And who else have I lined up? Maybe something about servo motors.
Excellent.
Specifically.
Excellent.
So, yeah.
Okay, looking forward to it.
Cool.
Okay, thank you again.